The environment beneath, around, and inside a hurricane has a major influence on how strong a storm can become. To visualize three of these influences, let's use North Fort Myers Community Pool as a backdrop and step inside a brand new NBC2 animation. Influence number one, water temperatures. A key ingredient for hurricanes to form is warm ocean water. If you think of the pool here as being the ocean, once the water gets to at least 80 degrees, a significant amount of heat is released into the atmosphere when the water from the pool, or in our case the ocean, evaporates. You can see this in action. When air rises, it cools and condenses into showers and downpours and thunderstorms. And the heat that it's pulling from the surface of the ocean helps to give things like tropical waves an extra kick. An important place to watch is here in the Gulf of Mexico between Cape Coral and Cancun. The Gulf Loop Current often holds some of the warmest waters in the entire Gulf thanks to underwater currents pulling it out of the Caribbean. This is a place where hurricanes can get very strong very fast. Hurricane Michael in 2018 is a great example, going from a Category 2 to a Category 4 as it moved over the current. Influence number two, the West African monsoon. Now, if you'd use your imagination for a moment, pretend that the pool deck here is Western Africa and the pool is the Atlantic Ocean. When this tropical wave right here moves off the western coast of Africa, it's able to get stronger the moment it hits the ocean because it's tapping into the energy that it's pulling from the warm waters below. Now, on years when the West African monsoon is more active, there's simply more tropical waves moving over top of Africa, hitting the Atlantic Ocean. This increases the odds that at least one or two of these tropical waves will find the perfect environment suitable for strengthening. Influence number three, eye wall replacement cycles. A major wild card in hurricane forecasting is accurately predicting when an eye wall replacement cycle is going to start and how long it's going to last. Take a look. Now, if we were to generate a giant hurricane over top of the pool here in North Fort Myers, we can get an idea as to what an eye wall replacement cycle might look like. These only happen in really, really big hurricanes over top of warm bodies of water like the ocean. Now, this hurricane, as you can see, is really, really well defined. See how clear-cut that eye happens to be? At the same time, though, this hurricane is likely tapping out on the maximum amount of energy that's available to it in the atmosphere. When this happens, a new ring of thunderstorms tends to form around the original eye wall. And eventually, this new secondary ring of thunderstorms will take over and become the new eye wall. During this cycle, the hurricane tends to get wider, but it also temporarily gets weaker. And that's why timing is so important. Last year with Hurricane Idalia, the storm weakened from a Category 4 to a Category 3 just before making landfall, because just before it made landfall, it started an eye wall replacement cycle. Now, this process can last anywhere from a few hours to more than a day. And despite all of the advances in modern weather forecasting, it is still very, very difficult to get an idea as to exactly when a cycle is going to begin. Reporting local from North Fort Myers Community Pool, I'm First Alert meteorologist Rob Duns, NBC2. Mid-May marks a major transition in our community's weather. As we move out of the dry season and into the South Florida rainy season, though, this is also the time of year when our neighborhoods are most vulnerable to wildfires sparked by single lightning strikes. How come? Well, typically in the middle of the month of May, the top few inches of the soil, like where the grass grows and a wildfire gets its fuel from, they are the driest they're going to be for the entire calendar year. But it's also that time of the year when our crystal clear blue sky can be interrupted by isolated thunderstorms on the sea breeze. In fact, according to FEMA, more than 55% of all of the wildfires in the United States that are sparked by lightning happen in a small window of time between right now and the month of July. Holy smokes! Now, obviously, there's not much you can do about where a lightning strike is going to hit, but your best offense is a strong defense. By making sure the plants and trees on your property are well maintained, well watered, and trimmed away from your home, you limit the fuel that a spreading wildfire could potentially tap into. Reporting local in Estero, I'm First Alert meteorologist Rob Duns, NBC2. You know, over the years, I've been very fortunate to work with a lot of our community's schools at teaching our area's kids kids about the weather. So for this Hurricane Week segment, I wanted to make something kind of geared towards your kids and your grandkids to help explain a pretty complex subject, and that will be the subject of storm steering. It is the steering currents around a hurricane that basically tell it where to go. Whether it moves right toward Florida or bends before it gets anywhere close to land, it's these storm steering features that play a really big role in determining where a hurricane is going to go. Something important to remember when we talk about this topic is to remember that the intense winds within a hurricane are not the winds that push it across the ocean. Instead, a hurricane almost has to be told where to go by winds that are outside the hurricane, pushing it in one direction or another. Kids, a way to think about this is to think of a toy like a spinning top. You know, if you were to throw a spinning top on the table like this, they will spin and spin and spin and spin and spin, and they'll spin for a long period of time, but they really won't ever go anywhere unless you physically push it in one direction or another. That's why hurricanes are somewhat similar to spinning tops, in that they can generate a lot of spin with themselves, but unless they're physically pushed in one place or another, they're never ever going to really move in any one direction. That is why another toy you can think about that helps explain this concept of storm steering is something your grandparents might be a little more familiar with, and that would be a marionette puppet. A marionette puppet is a puppet that is steered from up above, just like a hurricane in many respects. Now, if this puppet's going to do anything, the only way it can do anything is by being told by the controllers up above to move its arms or move its legs or to physically walk across the table. Here's how it's like a hurricane. A hurricane can be very, very tall. In some cases up above 45 or 50,000 feet. And it's the winds in the upper parts of the atmosphere that can push on a hurricane and push it in one direction or another. So just like our marionette puppet here, if the winds are very strong in the upper parts of the atmosphere moving that way, they will physically push the hurricane just like a marionette puppet is controlled from up above. So when it comes to hurricane steering, what you want to listen for with mom and dad and grandma and grandpa would be things like the Bermuda High, trade winds, and cold fronts, because those all act as steering features, just like the controllers of a marionette puppet, to push whatever we're forecasting to move in one direction or another. Reporting in the studio with little Rob Duns. I'm First Alert meteorologist Rob Duns, NBC2. Back to you. Have you ever heard that saying that it's good to think outside of the box? Well, that may very well be the case when it comes to hurricane forecasting. Let's talk about the concept of Hebert boxes, an idea from the late Paul Hebert of the National Hurricane Center. Back in the 1970s, Hebert noticed that a lot of major hurricanes that went on to make landfall in South Florida happened to move across two specific parts of the ocean. One here just east of Puerto Rico and another one here in the Western Caribbean. Now, it's important to say that this is just an observation, and there have been plenty of hurricanes that have moved through these Hebert boxes which have not impacted us in Florida, and other storms that have gone outside these boxes that have brought some really big impacts to our state. But from our community's local history, there have been some awfully notorious storms that have lived up to the idea. Irma and Donna both moved through Hebert Box 1. Ian and Wilma both moved through Hebert Box number 2. So though this concept isn't anything official, history shows us that if a big storm is on the prowl, we're better off if it goes outside the box.